Welcome to this workshop on how to increase your maintenance workforce by 35% without hiring anyone. My name is Eric Pierre, and in the next hour or so, I'm going to show you how you can increase the productivity of your existing workforce by 35% through implementing maintenance planning and scheduling. Your maintenance team will go from being overworked and under-resourced to finally being in control and having time to make more proactive improvements. You'll get more work done. You're going to reduce the cost, you're going to have less equipment failures, and you're going to experience a whole lot less stress. Now, I really want you to stay focused during this webinar so that you walk away knowing that you spent your time wisely. So please, turn off your mobile phone, close all the other windows on your computer, close the door and pay close attention for the next 60 minutes or so. It is going to be worth your time. You are in the right place if you are struggling to increase the productivity of your maintenance workforce, or if you need to get more work done with less people, if you need to significantly reduce your maintenance costs, or maybe you're here today because you want to finally start breaking down that reactive maintenance culture. Now, before we delve into the workshop, let me share a bit about myself. As I mentioned in the introduction, my name is Eric Pierre. I'm the founder of the Road to Reliability website and the online Road to Reliability Academy, for which we deliver world-class online training to anyone, anywhere in the world. For the last 20 years, I've worked in asset management and specifically maintenance and reliability in the upstream oil and gas industry. I've worked in the Netherlands, the United Kingdom, the Philippines, the Sultanate of Oman, and since 2013, I'm based in Australia. Now, everywhere I've worked, I've seen the same problems again and again. People in charge of maintenance and reliability are busy fighting fires, working in highly reactive environments, almost never a chance to look ahead and think about longer-term improvements, running from crisis to crisis. Now, as an industry, we know how we should manage maintenance and how we should improve reliability. But within individual organizations, this knowledge is often not there where it really matters. Too often, those in charge of maintenance and reliability don't know how to avoid the virus, or they don't have the skills to bring about the change that will stop the fires. And when those in charge of managing maintenance and reliability turn to the market for help, they're often let down for a number of reasons. Too often they end up getting a solution that is really just addressing one small part of the puzzle, and typically it's based on a piece of software that is being sold to them. And very often the frameworks for achieving reliability that are being offered to them are overly complicated. And that creates risks around focus and implementation. And way too often, education is neglected. You see, improving reliability is a marathon, not a sprint. It takes time, and often quite a bit longer than you'd want to hire consultants for. And let's be honest, hiring good consultants to change your business is an expensive thing. Not something most companies can afford to do for a long time. But you simply can't afford to ignore reliability either. That's going to cost you dearly. So the solution is simple. You need to achieve reliability mostly on your own. And to do this, you need a simple and effective framework. And you need an effective education solution that's going to teach your organization what they need to know and when they need to know it. You need a set of simple tools to help you implement the key elements of reliability. And you need a community where you can share experience and get advice from each other. And you need all this without paying top dollar all the time. And that is exactly why I started the Road to Reliability. That is exactly what we offer through our website. Now, in this workshop, we're going to talk about one of the 4 elements on the road to reliability, and that is maintenance planning and scheduling. Now, can you imagine what it would feel like to work in your organization if you had broken down that reactive maintenance culture, had increased productivity, and reduced costs and increased staff morale? Just imagine the change that would be. Now, here's one thing I want you to really understand. Your maintenance productivity is eroded each and every day because of the waste you have allowed to build up in your maintenance process. Implementing maintenance planning and scheduling is all about implementing a process that systematically eliminates waste. And by eliminating that waste, you significantly increase your productivity. you're going to get more work done with less people. And with less people on your books, you're going to be reducing your operating costs. And with less waste, you also have less frustration and you're going to improve morale. So, as we head into the rest of this workshop, remember this: maintenance planning and scheduling is all about eliminating waste. And with that said, in the next section of this video, I'm going to show you how waste occurs in maintenance, how planning is used to eliminate waste, and how we use scheduling to eliminate waste. And then I'm going to wrap up the main content section of this video, discussing why most organizations fail when it comes to implementing and running maintenance planning and scheduling. Alright, so let's start by looking at how waste occurs in maintenance. Now, before we talk about waste, let's talk a little bit about wrench time or productivity and what it actually means in a maintenance organization. When you hire technicians, you hire them to do maintenance. But in most organizations, maintenance technicians spend maybe a third of their time doing actual maintenance. And wrench time is simply a measure that shows how much of your technician's time is spent doing actual maintenance, and is typically expressed as a percentage. Now, back in 2007, Doc Palmer, the author of the Maintenance Planning and Scheduling Handbook, gave a presentation at the Shutdown Turnaround Outage Conference, where he shared his experience with many industrial companies. And over the years, Doc Palmer found that many companies, especially at management level, the levels of the organization that are further away from the front line, like to think that their wrench time or their productivity is somewhere around the 80% or so. Now, once these companies actually investigate their productivity, they find that it is often not far off the industrial average, which is somewhere between 25 to 35%. And many other industry studies and benchmarking exercises have found very similar numbers. And when you have an industry average wrench time of say 30%, that means only 30% of a technician's time is spent on doing real maintenance. And so only 30% of his technician's time is actually productive. Now, many people who first hear these numbers just don't believe it. And you can understand why, right? 30% productivity is shockingly low. But unfortunately, it's true. Now, let me explain how this happens. In the rest of this section, we're going to explore in detail how waste happens in maintenance organizations and how we end up with such low maintenance productivity. And we'll do that by exploring how a typical maintenance job happens in a reactive environment without effective planning and scheduling. So let's assume we have a maintenance crew that works a 12-hour shift from 6 in the morning to 6 in the evening. On the timeline that you see here, we'll mark all the activities that are happening throughout the day and we'll apply a simple color coding. Green for productive maintenance time, i.e. when your crew is actually doing hands-on maintenance work on the equipment. We'll use red for non-productive time when your crew is in meetings, waiting for something, looking for spare parts, etc. And we'll use black for break times. Now, at 6 o'clock in the morning, the day starts and the first thing that happens is the supervisor calls in the whole crew. The supervisor will discuss what is happening in the plant today, what work is being done today, and especially who's doing which job. By 6:30, most technicians will have been assigned their work and they start gathering their tools and materials. Now let's assume that takes about 30 minutes. So by 7 o'clock, the work crew is ready to work, but they're going to have to wait for the work permit to be signed on and for the isolation of the equipment to be completed. But it's a busy time, and so many other crews are waiting for their permits and isolations too. So this takes longer than it really should. Finally, by 8 o'clock, the work starts, and we start to see some green productive time on our timeline. By 9 a.m., the crew have been at work for 3 hours, so it's time for their morning break. They quickly make their site safe and head over to the break room. We have a diligent crew, so they work till 9 a.m. sharp and make sure they're back at their work site after their 30-minute break. And so from 9:30 onwards, the work continues and the crew is getting on with the work at hand until around 10:30 when they discover that they're actually missing a part to complete the job. And you see, the work order they received wasn't fully planned. Instead, it was what you typically see in a reactive maintenance organization, which is an unclear work request, from which then the supervisor had to assume a certain repair scope. Unfortunately, that scope didn't turn out to be too accurate. And so at 10:30, the job is stopped. One of the technicians goes to find the supervisor, and after taking a look at the job, the site supervisor and crew agree that indeed the additional part is required. So the crew heads over to the warehouse to request the part. They fill in the request and hand it over to the warehouse supervisor. And she gets one of the warehouse personnel to locate the part. After about 50 minutes, the warehouse clerk comes back and says he can't find the part, although the inventory system says there's still one in stock. Can't be found. Well, by now it's 12 o'clock and it's lunchtime. The crew agree with the warehouse clerk that after lunch they're going to come back and they're going to help him find the part. Chances are it's probably lying on the wrong shelf, but the warehouse clerk doesn't really have the technical knowledge to recognize the part, so he relies on the part numbers that are on the parts, which means it takes him a lot more time to find parts if they're not where they should be. And so after lunch, the crew are back at the warehouse at 1 p.m. sharp to help locate that missing part. It takes them about 45 minutes to find the part that was indeed mistakenly put in the wrong bin and the wrong shelf. Nobody knows how it got there, and by the looks of it, it must have been in the wrong place for a very long time. Anyway, with the part now available, the crew heads back to the work site to try and finish the job before the shift ends. And so at 2 p.m., the crew are back at work. 3 p.m. it's time for a break, and the crew head back over to the break room for their afternoon break. By 3:30, they're back at work and work hard to physically finish the job by 4:30. The crew mentioned to each other that it's a good thing they've done this repair so many times before, otherwise they would have never been able to finish it so quickly. And at 4:30, when they've physically completed the job, the crew cleans up the work site, close out the permit to work, arrange with operations to de-isolate the equipment and for the equipment to be brought online. They get all that done in about 60 minutes or so. So by 5:30, they head back to the office and do some last admin work, which includes completing their time writing sheets and giving the maintenance supervisor a quick update on how they got on with the job and how they had to help the warehouse clerk find the part. And so the day ends for our maintenance crew. They got their job done, but just look at that timeline. It's full of red, it's full of non-productive time. When I show only the greens, it becomes even more clear. The crew is really busy, but not very productive. They only got about 4 hours of actual maintenance done during their 12-hour shift. And 4 productive hours out of a 12-hour shift would give them a wrench time of 30%, which, as we discussed earlier, is pretty average across industry. And as we saw, that low productivity was not because our crew was lazy or just taking extra long breaks. No, not at all. The low productivity was the result of an inefficient way of working. It was the result of the work not having been planned properly. It was the result of not having an agreed schedule that everyone was working to, so the crew had to wait for operations. It was the result of spare parts not being available when the job was supposed to start. In short, the delays were there because this reactive maintenance organization did not run an effective planning and scheduling process. So as you can see, waste occurs in many ways when we execute maintenance. It can occur when we're having to look for materials or spare parts that were not identified on the job plan, or when we're having to find special tools that were not identified in the job plan, or maybe we have to go and find technical information on documentation on bearing clearances or torque values that weren't in the job plan. Or our crew could be waiting on others, whether that be operations to isolate equipment or other trades that are part of the job or external service providers. Now, these are all really common issues in organizations that don't have an effective maintenance planning and scheduling process in place. Now, maintenance planning aims to minimize part of this waste. And it achieves that by identifying everything you need to do a job and making sure those requirements are all in place before the job is started. Now, in brief, that means that maintenance planning aims to eliminate waste that occurs during jobs, so that jobs proceed efficiently, and our overall crew efficiency, our maintenance productivity, or our wrench time, goes up. And so maintenance planning is really nothing more than work preparation, i.e. getting work ready so that it can be executed effectively and efficiently. It's about making sure that everything that you need to do a job has been identified and is available before the job starts. This concept that planning really is just preparation is really important. You see, in many organizations, when people talk about planning, they associate planning with Gantt charts made in Microsoft Project or Primavera P6 or other software. Somehow planning has become a synonym for scheduling in many organizations. But it's not. Planning is not scheduling. Planning is all about the what and the how of a job. And the scheduling is much more focused on who and when. Or another way, and I prefer a better way to describe this, is that planning aims to eliminate waste that occurs during jobs, whereas scheduling aims to eliminate the waste that occurs between jobs. Now, it's really, really important that you understand the difference between planning and scheduling, and that you can effectively explain this difference to your teams, to your management, and to your leadership. Because if you can't explain it, they won't truly understand it. And if they don't understand it, then down the line they will simply become blockers in the planning and scheduling process, simply because they don't understand. Now, I've seen this happen time and again in different organizations around the world. So please, don't think this won't happen to you. So make sure you really understand the difference between planning and scheduling, and that you manage to convey this to everyone in your organization. So we said that maintenance planning aims to make sure that everything is available before a job starts. So how do we do that? What does a planner do when a job needs to be planned? Let's talk a little bit about what maintenance planning really is as an activity. And there are many ways of explaining what it means to do maintenance planning. But a simple framework that is easy to remember is what's called the 5 M's of maintenance planning, where the 5 M's stand for method, manpower, machine, materials, money. Where method refers to the work scope of the job and how you actually do the job, the procedures or method statements. Manpower obviously refers to the labor you need, the skills or the trades, and the durations of those activities. Machine is the actual equipment on which the maintenance is to be completed, but also talks about the tools and the specialist equipment that you may need to hire to do the job. Materials, fairly obvious. This is all the spares and materials and consumables needed to do the job. And the last M, money, is pretty obvious too. This refers to the costs involved in doing the job. And part of a planner's job is to put a high-level cost estimate together before the job is done. And you may sometimes come to the conclusion that a major repair may work out with such high costs that it's just not economical, and you might as well replace the equipment completely. Now, these 5 M's are really just a simple memory jogger. But the problem is, this is not really a very comprehensive list of what you may need to fully plan a job. So I prefer to use the following table, which is still aligned to the 5M module, but it gives you a much better idea of what you need to fully plan a job. Let's have a look. Under method, you'll see the work scope, i.e. what needs to be done. The method statement, how the work should be done. And whether you need specific company or OEM procedures that should be adhered to. Are there isolation requirements to make sure the job can be completed safely? Specific technical data like torque values, clearances, etc. Technical drawings and relevant sections of equipment manuals. What special access requirements are there? Do you need a scaffold? Do you need a cherry picker, a mobile crane? What rigging and lifting requirements do you need to have? Do you need a specialist crew, or can your own mechanics do the basic rigging and lifting that needs to be done? Are there special safety precautions associated with the work? And once the job has been completed, are there specific testing and reinstatement requirements to demonstrate to operations that the equipment is functioning properly? Now, this is especially important if you've maintained safety devices. But also think about doing, for example, vibration measurements after you've changed the bearing, or if you've done a major overhaul on a large centrifugal pump, that as part of the reinstatement process and handing over the equipment back to operations, you may want to do a performance test. You want to make sure that the pump delivers the flow rate at the required pressure that it's supposed to do. Yeah, we want to make sure that that pump is fully functional before we hand it over. So as you can see, there really is quite a lot in that bucket of method. When it comes to the manpower bucket, the M for manpower, you want to identify your own internal labor that you need to do the job. You need to determine if you need any external services. Do we need some additional mechanics because we'll be short given the size of the job? Or do we need someone with specialist qualifications or a skill set that we don't have internally, like a specialist welder or a certified inspector? And of course, part of this is also identifying the job duration so that we know how long we need that labor for. Now, under the heading machine, you would expect to cover what equipment are we maintaining? What special tools are we required? Now, are those the kind of tools that your technicians would have in their tool set, or are there special tools and would we therefore maybe need to reserve them from a central workshop? Or maybe we need to hire them from a specialist service provider? And if so, we need to make sure that that special tool set is on the site before the job can commence. And maybe you need to hire other equipment. Do you need to hire scaffolding? Do you need to have a crane? Under the M for materials, you want to make sure you have identified each and every spare part you need to complete with vendor details, part numbers, quantities, etc., so that procurement can order these without any delay. Now, maybe you also need generic materials like cabling or instrument tubing or instrument fittings. Do you have any specific consumables that you might need a lot of and therefore you may need to check with a warehouse or procurement that there's enough in stock before you start the job? And finally, part of this should also be the staging and kitting of the job. Now, I would discuss this intensively in the course, but one of the roles of the maintenance planner is to ensure that all spares and materials are put together in a box or a container so that it can be easily picked up by the technician on the day of the job. Or maybe even better, deliver it to the worksite before the job starts. But the key thing is that you make sure that all the materials are there and all the tools are there and they're staged and they're ready to go when the work commences. And finally, the M for money. Now, you obviously need to cost all those resources, and that includes internal labor, external labor, parts, materials, hire equipment, everything. But you may also want to indicate the loss of any revenue that might occur if the job requires downtime that impacts production. And ultimately, you need to have a total cost for doing the job so that you're going to make a final decision whether you proceed with the job as planned or not. As I said earlier, sometimes you may come to the end of this planning process and you may realize that it might be cheaper or more cost effective to replace the equipment with new. Now, once your planner has identified all these requirements and documented it into a single coherent and concise work pack, and we know that all the services and materials have been ordered, then you can deem the work fully planned. And that means we have identified everything that we need to do the job, and that we have initiated all the necessary processes to acquire what we need to get from outside. Now, at this point, there is nothing left to do for the planner other than to wait until all required parts and materials and tools, etc., arrive on site. And then you want your planner to do a final check. And so it's important that you actually set this status of fully planned on the work order in your CMS, because that allows your planner to keep track of what work still needs to be planned and what work has already been fully planned. Now, work that has been fully planned only needs to be monitored for availability of parts and services. And once those are confirmed to be available, and the planner has physically checked that all the parts are there and correct, the work order can be set to ready for execution, which is another important status you want to have in your CMS, because that is the handover to the scheduler. Now, the concept of ready for execution is really important, but it's going to have to be discussed another time because we'll run out of time on this workshop. It is something I discuss in detail in my online course on maintenance planning and scheduling. Now, so we've talked about what planning is and what a maintenance planner needs to do to make sure jobs can get executed smoothly, efficiently, with minimal delays and waste. But what does it actually look like? The first thing to realize is that the role of the maintenance planner is not a desk job. A good maintenance planner spends a lot of time out on the plant, diagnosing the problem, scoping jobs and job sites, and speaking to the maintenance supervisor or maintenance technicians to understand site constraints, site access, mechanical handling, but also potentially thoughts and advice from technicians and the supervisor on how best to do the job. Now, a lot of the information that needs to go into the work pack can only be obtained at site, and some of it has to be validated at the job site before the job plan is finalized. And when a planner walks around your plant scoping jobs, it should be hard to distinguish the planner from, say, an operator or a supervisor. And once the planner has done all the site verification and scoping, he or she will return to the office and put down a clear and concise scope of work to create the work order in CMS and to break the work scope down into the necessary steps. Your planner will need to check existing standards and procedures to see which of these must be used in which steps of the job. The planner should be identifying specific safety precautions. You want your planner to identify hazards that are unique to the specific job or the specific equipment. That could be because you are pressure testing or maybe blasting or welding. It doesn't really matter. The planner needs to identify the key hazards and identify what non-routine controls you need to put in place to make sure the work can get done safely. Now, the requirements for this will vary from organization to organization. And some organizations don't want their planners to do this. But personally, I feel very strongly that identifying how best to manage specific hazards associated with the job is a key part of a planner's role. And of course, you need to make sure your planner is going into your CMS and identifying all the parts and materials and consumables needed to do the job, and then to raise the necessary requisitions to get those materials and parts in place. And the same goes for calling off external contractors or hiring equipment. And in the end, all this is then documented in the work pack. I'm not going to delve into the concept of work packs here in any detail, but just going to share with you that a work pack is essentially everything you need to do a job safely and efficiently. Nothing more and nothing less. So in some cases, a work pack is just a couple of pieces of paper with a printout of the CMS work order. For other jobs, it could be a heavy binder full of technical documentation and drawings. So you can see that a planner's role does really have a significant office-based component. But it is not an administrative role. It is very much a technical role. Now keep that in mind, because when you come to selecting your planners, you need to make sure you're recruiting people with the right kind of technical expertise. Now, another place you want to find your maintenance planner is in the warehouse. And the first thing that the planner needs to do when he or she is in the warehouse is to make sure that when parts arrive, that they are checked to be the correct parts and in good condition. Now, you could use a quality inspector, and bigger organizations often do this, but I'm not a big fan of it. You really want to have your planner owning this so that if something goes wrong with the materials, there's clear accountability and clear ownership. It's not unusual that a planner orders the wrong part by mistake, or just because supplier part numbers are confusing, or because the planner is not 100% sure about what equipment or what parts are really installed. Now, a quality inspector will just have the purchase order to go by and won't have the background knowledge that the planner has. And so, if the part that has been ordered is the part that has been delivered, your quality inspector would just tick everything off saying, that's fine. But when your planner looks at the same part, he or she might just realize that the wrong part was ordered. So instead of allowing the work order now to progress and go into the weekly schedule and then fail in practice because it turns out to be the wrong part, the planner can actually identify this, put the job on hold, return the part and order the correct part, and thereby avoiding all this waste in the execution of the job. The second thing that your planner needs to do is to make sure that all the parts, all the materials, and all the tools for the job have been staged and kitted. Now, that doesn't mean that the planner has to do it himself, but you want to make sure that your planner checks that the work really is ready to go. And that is when your planner puts the ready to execute status on the job in the CMS. So to summarize, Through maintenance planning, we eliminate waste and we improve efficiency by ensuring everything we need to do a job is in place before we start the job. So we have now seen how waste occurs in a maintenance process and how we use maintenance planning to eliminate some of that waste. Which then begs the question, why would we schedule? Why bother with scheduling? We've just planned the work. Isn't that enough? How does scheduling add value? And how does it eliminate waste and increase productivity? Well, the thing is, planning alone, even world-class planning, is not enough. If you stick to all the planning principles and have a really effective planning function in place, it will not get you very high productivity. It's not going to make sure that a lot more work is done. What it will do is that individual jobs get done better. Planning is focused on preparing individual jobs, so those individual jobs will indeed get completed more efficiently. But experience and various benchmarking studies and literature have shown that planning without scheduling has almost no sustained impact on overall productivity. And the way to explain that is by using two simple laws. Two laws you've all heard about. And the way to explain that is by using two simple laws. These are laws we have all heard about and probably experienced at some point in time. The first one is Murphy's Law, which pretty much states that whatever can go wrong will go wrong. And this is exactly what planning is all about, right? It's about preventing jobs from going wrong. Planning jobs is about making sure they are executed safely and efficiently without problems. And planning is about anticipating problems that might occur during a job and making sure we're ready for those, especially on big jobs like major overhauls or shutdowns. This becomes really important. Now, when it comes to scheduling, we're dealing with another law. That is Parkinson's Law. And Parkinson's Law states the amount of work assigned will expand to fill the time available. Let me repeat that. The amount of work assigned will expand to fill the time available. Now, this law was postulated by the economist Cyril Parkinson in an article of The Economist in 1955. And in practice, it's just a reflection of human nature, right? If I need to complete 2 tasks today, I will get those done and then I'll figure out what I'll work on next. But if I'm well prepared and have a detailed list of 6 things I need to do today, the pressure is on, and I'm going to get those 6 things done, or most of it. And that is what scheduling is all about. Scheduling is essentially goal setting. It's goal setting for your maintenance crew. It's about giving your maintenance crew a clear list of things to do that week and making sure they have the resources to complete that list of work. You don't want your maintenance crew to wake up in the morning, walk into work, and figure out what they're going to do. It's just not efficient. Now think of it this way. If you wake up in the morning with a list of 5 things to do, you will get more work done than if you just wake up. Well, it's the same with your maintenance crew. So just to remind you what we discussed earlier about the difference between planning and scheduling. Planning reduces delays during jobs. Planning is about making sure that individual jobs can be completed efficiently and safely. Scheduling reduces delays between jobs, and so scheduling really is about making sure your whole crew gets as many jobs done as possible. Now, through good scheduling, you're going to increase productivity in a few ways. The first way is through goal setting. We already talked about how scheduling is a form of goal setting. You're going to give a clear set of expectations to your crew about what amount of work you expect to get done in a week. And apart from goal setting, that drives discipline. Because you measure how much of that work does indeed get done, and you can have a meaningful conversation with your teams about whether enough work is getting done or not, and if so, why. But scheduling also increases productivity by grouping work efficiently. Now, you can achieve this by grouping work that is in the same location, and thereby reducing travel time. You can group work that is done on the same equipment, which means that you can potentially reduce the number of equipment isolations and de-isolations. You can increase efficiency by getting all the same type of work done in one large campaign. And another way scheduling drives efficiency is that it enables staging to happen. And with that I mean that by having a clear frozen weekly schedule, you know exactly what work you're going to be doing next week. And then you can make sure that all parts, all materials, all tools, all consumables, etc. are all organized for next week. And you can make sure that everything needed for next week is neatly packed in a box, marked up with the work order details, and ready for your crew to just pick up and start the job. Or, like we mentioned earlier, you can even go a step further, like some plants do, and they actually have the boxes with all the required tools and materials delivered to the job site. The point is, you can only become this organized, this efficient, this proactive if you have a frozen weekly schedule that everyone is working to. You can only achieve this if you are scheduling. And that brings me to another way that scheduling contributes to improving productivity, and that is coordination. By having that frozen weekly schedule, you can make sure that the different trades required to a job will be at the worksite when required. You can make sure that operations have isolated equipment from the process. And you can make sure that work permits and other work authorizations are all in place in advance, because everyone knows what work will be done, where, and on what equipment and on which day. That level of coordination reduces a huge amount of waiting times and therefore really increases productivity. So we've seen how waste occurs in maintenance and how we use planning and scheduling to eliminate a lot of that waste. And although I haven't talked about all the different elements of a proper planning and scheduling process, I'm sure by now you've realized that it's not all that complicated. In fact, maintenance planning and scheduling is pretty simple. Unfortunately, it's not easy. And many organizations around the world, in fact probably most, just get it wrong when it comes to planning and scheduling. You see, most organizations think they plan and schedule their maintenance work, when in fact most organizations plan or schedule. Very, very few organizations actually plan and schedule their maintenance work. You see, most organizations tend to focus a lot of effort on scheduling, on Gantt charts and all those kind of things. And then they end up having to plan the work on the fly. But high-performing, world-class organizations first plan the maintenance work, and then they schedule what was planned. And as we've seen, planning and scheduling are two very different things, with very different requirements. But you need both to create a maintenance environment that is efficient. We need planning and scheduling to work together in an efficient process. A process that systematically eliminates waste. There are many variations of the basic planning and scheduling process in use around the world. Every industry, every organization has its own unique view on things. And they all have their own unique planning and scheduling processes, all slightly different. And that's fine. But in all cases, the effective planning and scheduling processes come down to the same basic 6 steps. And they are the identification and prioritization of maintenance work, the planning of that work, the scheduling of that work, followed by, of course, actually doing or executing the work. Then properly closing out the work. And then a final step is a review of our performance with a view to improving. And those are the 6 key elements of planning and scheduling. Now, of course, you need to break this process down into much more detailed steps to get to an effective end-to-end business process. But we don't have the time to go into that here. And when you successfully implement and embed a maintenance planning and scheduling process like this in your organization, you can increase your organization's wrench time from the typical industry average of 30% to 45% and potentially more. And when you have moved your wrench time from that 30% to 45%, you have effectively increased your workforce by 35% without hiring anyone. Now, let's talk a little bit more about some of the main reasons why organizations get maintenance planning and scheduling wrong. And one of the most common reasons is that many organizations actually don't understand the difference between planning and scheduling. Now, hopefully, after being through this presentation, you won't have this problem. By now, you will understand how different planning is from scheduling. And you will understand why you need both planning and scheduling to eliminate that waste from your maintenance process. Another common problem is that organizations don't treat planning and scheduling as an end-to-end business process. They see it simply as a collection of tasks that some people do. But if you don't bring all the separate pieces together in an efficient and effective process, you will simply end up with a lot of waste, rework, and inefficiencies. And by not treating it as a business process, you're unlikely to be approaching it from a continuous improvement angle. And if there's one secret I want to give you, if there's one secret to successfully managing maintenance planning and scheduling, then it is that you need to drive continuous improvement and get better and better and better at it. Now, one of the most common problems why organizations fail with maintenance planning and scheduling is simply because they don't make the necessary resources and systems available. If you don't have a maintenance planner and you don't have a scheduler, then it's going to be really hard to run an effective maintenance planning and scheduling process. And if you don't set up your CMS with the required work order statuses and other basic planning and scheduling functionality, you're going to struggle to make the process work. And another common mistake that is closely related to this is where organizations reluctantly accept the need for a maintenance planner, for example, but then they don't appoint the right person into the role or don't give him or her the time to actually do the job properly. And they end up using the maintenance planner for all kinds of other things than actually planning maintenance work. In fact, maintenance planning is an area where so many mistakes are made that I have a whole lesson dedicated to the 12 most common maintenance planning mistakes in my online course. Another very common problem is that organizations eventually realize that their maintenance productivity is poor and therefore set out to improve it. They try to implement maintenance planning and scheduling, but they do it poorly, without structure, without discipline, without addressing basic change management practices. And the end result is that after a few months or maybe even a year or two, everything that was implemented has slowly but steadily, surely fallen apart. Either because it never really worked, or because the people never really bought into the change, or because several key people were keeping the process together and they have moved on to new roles in the same company or maybe elsewhere. Now, I've seen this happen again and again, and it is such a waste, and it doesn't need to happen. I've come in organizations where we've had to redo the whole implementation for a second time because the first time was just not done in a way that was sustainable. Now, you just need to make sure you implement planning and scheduling using a proven framework, and that you're serious about it and you do it well, and it will yield huge benefits for many, many years to come. And I guess all these reasons are underpinned by one common theme, and that is that too many organizations simply don't understand. They don't see the value that planning and scheduling can bring to their organization. And often this is the case because they lack the knowledge. All they have ever seen is the reactive firefighting maintenance culture. And they just don't know, or they don't believe there is a much better and much more valuable way to run maintenance. And so many of these organizations are stuck with a reactive maintenance culture. A culture with low morale, high costs, high stress, and let's face it, shockingly low productivity. Now, on the other hand, those organizations that have implemented these principles of effective maintenance planning and scheduling, they achieve wrench times and productivity of 45% or more. And as I said earlier, getting to those kind of performance levels is not complicated. But unfortunately, experience does show that it's not easy either. So the question is, would you like to learn how to successfully implement maintenance planning and scheduling in your organization? Now, chances are you're here watching this because your maintenance productivity is not what it should be. or because your maintenance costs are higher than they should be, or because you're struggling to overcome that reactive maintenance culture. Or maybe, like many organizations, you're here because you're struggling with all of the above. Now, at this point, the way I see it, you have two options. Option one, you don't implement maintenance planning and scheduling. You continue to suffer from the overtime hero syndrome. You're going to continue to run from fire to fire, and you're going to continue to waste resources and suffer unnecessary stress. This is unfortunately the path that many organizations are on and will continue to stay on. But you have a choice. You can opt for option two, where you do implement maintenance planning and scheduling, and you will steadily eliminate the waste in your maintenance process. You're going to increase your productivity. The firefighting will slow down, and you will find over time that you become more proactive and morale improves. Now, when it comes to maintenance planning and scheduling, there are no secrets. The maintenance planning and scheduling process has been well documented in a number of fantastic industry books. My favorite one is written by Richard Doc Palmer, and I actually refer to it in my course. Now, why am I telling you this? As I said earlier, the problem with maintenance planning and scheduling is not that it's difficult or complex or hard to understand. The problem is that most organizations don't follow the complete process. Instead, they pick and choose parts of it, the bits that they like, but that doesn't work if you have a subjective and inconsistent way of prioritizing new work requests. That's going to create havoc with the rest of your process. You need to implement the end-to-end process completely, and you need to implement it well. And that's the other problem. Many organizations fail to implement maintenance planning and scheduling, and they never really realize the gains they set out to achieve. So I can't tell you any secrets. I don't have access to anything that is not already available in the public domain. However, I do have a very good framework to teach you the end-to-end maintenance planning and scheduling process, and I have a proven framework that shows you how to successfully implement it in your organization by combining key project management and change management practices. So if you're ready to implement maintenance planning and scheduling in your organization, and you want a proven framework to do so, then I'd like to personally invite you to join the Road to Reliability Academy and take our course in implementing maintenance planning and scheduling. Now, my online course in implementing maintenance planning and scheduling is the only online course of its kind. Not only do I teach you the ins and outs of maintenance planning and scheduling, but I also teach you how to successfully implement it in your organization. But apart from being unique because it's fully online, and because it teaches you how to implement maintenance planning and scheduling in your organization, this course is also unique because it's the only online course in the world in maintenance planning and scheduling that is certified by the Society of Maintenance and Reliability Practitioners, the SMRP. Now, that in itself is a big deal. Alright, let me tell you a little bit of what you learn by the end of this course. You're going to understand the end-to-end process of maintenance planning and scheduling. You're going to understand the key roles in the planning and scheduling process, particularly the maintenance planner, the scheduler, and the supervisor. You're going to understand the importance of work prioritization and the different methods you can use. You're going to learn how to plan maintenance work and understand the reason for the maintenance planning principles. You will be able to explain the difference between planning and scheduling, and you will learn how to develop a weekly schedule and how to determine what work goes into the schedule first. You will learn how to deal with emergency maintenance work so that you don't lose control and avoid slipping back into that reactive work environment you're trying to escape. You're going to learn how to effectively manage your maintenance backlog, including what categories of backlog you should use, how much backlog you should have, and how to monitor and manage your backlog. You're going to become familiar with the most important metrics to monitor the performance of your planning and scheduling process. And you're going to learn how to implement maintenance planning and scheduling using a proven implementation process that includes key project management and change management principles. And very important, you're going to learn how to build a business case to sell the implementation of planning and scheduling in your business and how to sell it to your leadership. Now, ultimately, This course will give you everything you need to successfully implement maintenance planning and scheduling in your organization and effectively increase your workforce by 35% without hiring anyone. Now, let me walk you quickly through the course modules. In Module 1, we're going to cover the course objectives. We'll go into the details of exactly what you'll learn and how we're going to work together. Module 2 is the Introduction to Maintenance Planning and Scheduling. And after a brief exploration of the role of maintenance in asset-intensive industries, we're going to explore why we need planning and scheduling in more detail. We're going to cover the increase in productivity and what that means for the bottom line of your business. Module 3 is all about how maintenance work needs to be initiated and prioritized. Creating good quality work requests and prioritizing properly is key to your success. If you fail to get this right, you are not going to get out of that reactive maintenance mode. Module 4, Plan Work, is all about maintenance planning, why it is important, the 6 planning principles that underpin sound maintenance planning, and we're going to talk a lot about roles and responsibilities because this is where many organizations go wrong. Module 5, Monitor Work, addresses a step in the planning and scheduling process that is not often talked about, but it's key to your success. And this module is all about making sure that work is ready to execute and marked accordingly in your CMS. Module 6 tackles scheduling, and we're going to talk about why planning on its own is not enough, and we're going to talk in detail how you use scheduling to increase productivity. We'll explore the 6 scheduling principles and how to create and manage a frozen weekly schedule. Module 7 is all about executing the maintenance work that has been planned and scheduled. This is the core of the process. This is why we do it, right? To get efficiency in this step. Module 8 covers the closeout of work. Now, the secret to successful planning and scheduling is a continuous improvement loop, and that relies on good, proper closeout of work and high quality feedback. Module 9 is all about making sure things are getting better and better, or in other words, continuous improvement, and how to build that into your business and into your work processes. We're going to talk about performance metrics, lean practices like Gemba, and we're going to talk about the concept of process ownership. Module 10 is where this course is really very different from all the other planning and scheduling courses out there. In this module, I'm going to give you a tried and tested process to successfully implement planning and scheduling in your organization. And when you complete the course, you're going to get a certificate of completion that you can use to share your accomplishment. But just as important, you're going to get lifetime access to all the course materials, the course discussion forum, and all the extra resources. And that's going to be really helpful because once you're in the middle of your implementation, or maybe after your implementation, 2 years down the line, and you have some questions, you have some doubts, you can simply hop back into the online course environments and refresh your knowledge, or join the discussion forum and ask that question that is burning in your mind. Now, you can't do that with any face-to-face course, that's for sure. So if you're ready to get started, you've got some options. If you simply want to enroll yourself or someone who works for you, you can do that as a single student with one payment of $1,295, which will give you full lifetime access to the course and all the materials. Right now, all you need to do is to go to roadtoreliability.com/MPS and you'll get all the details. You can enroll right away and get started. That's roadtoreliability.com/MPS. Now, if you want to enroll multiple students, I do offer group discounts for more than 10 students. Discount starts at 25% for 10 students and increases as you enroll more students. Now, at the moment, there is no automated process for group purchases, so just drop me an email and we can get that sorted. But if you want to enroll yourself, then head on over to roadtoreliability.com/MPS. Now, here's a question. How many face-to-face courses have you attended where you walk out after the first day and can ask for your money back? Not many, that's for sure. But the Road to Reliability has been created to help maintenance and reliability professionals around the world. And I firmly believe in that mission, and I believe in the value of serving our community. I also believe 100% in the quality of this course. So much so that if at any time in the first 30 days of the course that you are not happy with the course, for whatever reason, you can simply ask for a full refund, and I will promptly pay you back 100% of the course fee. So, when you're ready to enroll and you head on over to roadtoreliability.com/MPS, you will come to this page where you can review what is included in the course. And when you click on one of the Enroll Today buttons, somewhere on that page, you're going to be taken to the checkout page. And on the checkout page, you just fill in your personal details. You do need to create a password to log into the course area, but don't worry if you forget that password because you can always reset it later. Now, if you want to buy the course for an employee, just enter their email address and they will get the instructions on how to log in. For now, make sure you fill in your own name so there are no issues with the billing process. And once you filled in your details, enter the payment details and simply click the Place Order button. Once you click that yellow Place Order button, your payment is going to get processed and you're going to be taken to the confirmation page. From there, you can enter the course area directly by pressing the Access Course button that you can see at the bottom there, or you can access the course via the confirmation email that you're going to receive. And you're going to receive 2 automated emails. The first is an order confirmation with payment details and an order reference number. And this email is sent when the order starts being processed by the system. The second email you will receive once the order and the payment have been fully processed. Now, this could be a matter of minutes or sometimes 10 or 15 minutes. The second email also gives you instructions on how to access the course, how to reset your password if you need to, and the first few things you need to do once you log into the course area. So please do read this email carefully and please follow the instructions. It will really help to improve your learning experience. When you click on the login link in the email, you're going to get redirected to the login page. Just enter your email address and the password you created on the checkout page. If you can't remember that or simply want to reset it, click the Forgot Password link and follow the instructions to reset the password. And then once you enter the course area, you're going to see the course Implementing Maintenance Planning and Scheduling under the heading Your Courses. Simply click on the course image and you're going to be taken to the course overview page. And this is the course overview page. Now you're going to get here either by clicking on the course tile I just talked you through, or if you have pressed the Access Course button on the confirmation page just after checkout. Now, this course overview page outlines the course. It's going to list all the modules and all the lessons. And to actually get into the course, you simply press the Start Course button on the right. And that takes you straight to the welcome page where you can watch the welcome video and get started. So if you're ready to enroll, all you need to do is head on over to roadtoreliability.com/MPS and you can enroll as a single student, either yourself or for someone who works for you. If you want to enroll multiple students and you want to use the volume discount opportunities, then just drop me an email and we can get that organized. In the rest of this session, I just want to talk you through some of the most frequently asked questions about implementing maintenance planning and scheduling. And I'll start with one of the most commonly asked questions. And in this case, Jean-Marc from Canada and Travis from Ohio were the first to email in variations of this question. And the question is, how do we start? I presume that my bosses will give me the same budget, maybe even less with COVID-19. So how will you cope implementing new stuff when it's firefighting every day? That's a great question. And of course, as always, the answer does depend a bit on your situation. Now, the most important point to make here is that implementing maintenance planning and scheduling does not have to be expensive and should not be a major impact on your budget. But yes, you will have to free up some internal resources to develop your new processes and your systems and then to project manage the actual implementation. So what you need to do is you need to get a senior leader on board. You need to get a leader on board who shares your vision for increasing productivity through implementing maintenance planning and scheduling. And the best way to do this is by creating a clear and concise case for change that shows the value that your organization can gain by becoming more productive, by breaking down that reactive maintenance cycle. Now, if you haven't already read my article, How to Sell Planning and Scheduling to Your CEO, I would highly recommend doing it because it outlines a very practical approach on how to pitch the value of planning and scheduling in your organization. And that's step one, to get a critical mass behind the implementation of maintenance planning and scheduling. And once that's done, you do need to set up a small project team. You need to start educating the right people, and you need to start developing the planning and scheduling process for your organization, and you need to start getting ready for a structured implementation. And that is something I teach in depth in the course itself. Now, this is all premised on the idea that you do have an existing CMS in place, and that you do have a work order management process in place, and you have some kind of preventive maintenance program. If that's not the case, and you are highly reactive, and you're experiencing lots of breakdowns, you may need first to tackle your worst performing equipment and create some stability in the workplace. You see, eliminating those worst performers, those bad actors, can also be a very effective way of getting the organization to realize that there is a better way to manage maintenance than to run from fire to fire to fire. The next question I wanted to address is this one, which once again was asked several times in different shapes and forms, with the first email coming in from Junior in South Africa. And Junior asked specifically, are you saying we don't have to hire an expensive expert to implement maintenance planning and scheduling, that we can do this ourselves? And the answer is absolutely. You can do this by yourselves. You most certainly do not need to hire expensive external experts or consultants. I have developed my online course such that it teaches organizations everything they need to know about maintenance planning and scheduling and how to effectively implement it in their organization. There really should be no need to hire an expert to help you implement it in your organization, as long as you get a number of key people in your organization through the course and then implement what I teach. Now, what I teach is what I've used myself in the past, and there really are no secrets to it. You simply need to learn the key principles and avoid the common pitfalls, and then just follow the process and implement it. It's all there in this course, and you really do not need to go and hire external experts. You can do this. Now, another commonly asked question was, can we do this without a CMS? And in the case of Bassam from Oman, the question was, well, does our CMS have to be fully populated before we implement planning and scheduling? Now, let's tackle the first question first. Can we do this without a CMS? You could implement planning and scheduling without a CMS, but in this day and age, I would not recommend it. CMS software is easily accessible and highly affordable nowadays. You could apply what I teach in this course using a paper-based work order system, but to be honest, I think you would get much better value from your money and from your effort if you first implemented a basic CMS to manage your maintenance work orders. So no, don't try and do this without a CMS. Now, for the other part of the question, does your CMS have to be fully populated to implement planning and scheduling? There we have a bit more nuance, we have a bit more room to play. If your CMS is reasonably populated, in that you have a lot of your assets in place and you do have some kind of work order flow in place and you have some kind of preventive maintenance program in place, then yes, it probably will be perfectly fine to implement planning and scheduling, and you can use the extra time you create from your increased productivity to further improve your CMS or your preventive maintenance program. However, if you only use your CMS to track reactive maintenance work orders and you have almost no preventive maintenance in place and many assets are still missing, then again, you're probably better off first getting your assets in your CMS and getting some basic PMs in place to address those dominant failure modes you're experiencing. And now we come to one of the most common issues. And in this case, the first to email in with this question were Harun from Turkey and Frank from North Carolina. In essence, they're asking, how do we convince the production department to give us time to execute maintenance? We run 24/7 and just don't have the time for maintenance until we have a breakdown. And although not directly a maintenance planning and scheduling question, it really is the age-old question that many maintenance organizations around the world struggle with. So I thought I'd tackle it here to some degree. And there are a few aspects to my answer here. First, you need to understand whether for your specific organization, applying planned preventive maintenance would lead to less downtime, lower costs, and a better business performance than the reactive breakdown maintenance mode you're in. Now, in almost any asset-intensive industry that runs 24/7, that will be the case. You see, breakdown maintenance is notoriously expensive. Experience and industry sources show it's probably at least 3 to 4 times as expensive as planned preventive maintenance. And you can understand why, right? Breakdown maintenance is planned on the fly and therefore much more prone to all the sources of waste we discussed earlier in this presentation. A breakdown culture also often leads to higher inventory needs and more overtime, and usually to more downtime, which means less uptime and less production. And that's the angle you need to take with your colleagues in production. You need to be able to show them a clear and objective analysis that shows that when you conduct preventive maintenance, your downtime will reduce. That means your production will increase because uptime goes up, and in parallel, your costs are going to come down too. But here's the thing. You can't just expect people to change their ways of working, their behavior, just because you say so. It doesn't work like that. And that brings me to the second part of this answer. You need to apply some basic change management practices and help your colleagues in production to look at things differently. You need to educate them on why breakdown maintenance is expensive, why it is inefficient, and why it actually leads to increased downtime and therefore less production. You need to show them a clear case of change that summarizes how things will improve by changing the way of working. And that case for change needs to clearly spell out how the change will improve things for them, for the production department. Now, one last piece of advice here, which is really important. Make sure you really understand the failure modes you need to manage, because I've seen far too often that maintenance teams embark on these kind of changes and they introduce preventive maintenance plans. They introduce a lot of PMs that require equipment to be down. But then down the line, they have not improved equipment reliability. So the net effect is that the overall downtime increases and production decreases further. And that is surely going to destroy your case. And you're not going to get your production brothers on board with that. So you need to understand your failure modes. You need to understand why your equipment is breaking down. And it is often the case in reactive maintenance organizations that these failure modes are best eliminated, or sometimes only can be eliminated, by improving the equipment design or operating practices. Very often, it is not about doing more maintenance. So you need to understand that you need to address that, because otherwise you're only going to increase the downtime by adding more maintenance to the system. Right. The next question comes from Wallace in Brazil, and he and a few others with him asked, how can we even hope to plan? Lead times on spare parts are always too long, procurement takes too long to process our orders, and suppliers never deliver on time. Yeah, so this is a very common issue. It's something many maintenance organizations struggle with on a daily basis. And having worked in many places around the world, including countries with some pretty difficult supply chains, I can totally relate to the issues and the frustrations around getting access to parts and materials. And of course, we do need to improve the performance of our supply chains and our suppliers. We need to get our suppliers to deliver on time, to keep their promises. But that's not our job as maintainers. As maintainers, we need to get our maintenance processes under control. We need to get to a point where we have less high priority urgent spares requirements. And we need to get to a more predictable flow of parts and materials. And we do that by improving reliability. Yeah, that takes time. And we do that by ensuring our inventory is set up based on our actual material requirements. But we also do it by implementing a robust planning and scheduling process. You see, if you get a proper planning and scheduling process in place, you will improve the way you prioritize work. Instead of everything being an urgent priority that needs to be fixed today, You're going to prioritize your work requests based on risk. Risk to safety, risk to production, risk to cost. And by taking that view, you're going to see a lower amount of emergency work coming through, and therefore you're going to have less stress on your supply chain. And equally important is that with planning and scheduling, you're not going to be scheduling or executing work where the materials haven't arrived yet. You're only going to schedule and execute work once the materials are on site and have been checked. And that avoids that very common issue that work gets scheduled on the assumption that materials will arrive on time, and then when they don't and the job is in progress and materials are not there, the job slips and it just creates chaos and frustration. I always say to maintainers that before we look to improve the performance of our supply chain and start working with our supply chain colleagues, we really need to get our own house in order. And implementing planning and scheduling helps a lot. It creates a more stable working environment where we have better control over what spares we need and what parts we need when we need them. Alright, the next question came in from Daryl in Idaho, and he asked, what's a good planner to tech ratio? What about the schedule? Does it matter if you've never scheduled before? Okay, so there's a few questions there. A good planner to tech ratio would be probably about 1 to 20 or maybe even 1 to 30. But you could only ever achieve that if you have a well-embedded and really mature planning and scheduling process with well-prepared standard job plans for all your PMs and for most of your corrective tasks too. And you'd need to have a good library of technical documents and drawings and manuals, etc. So if you're just starting out and you're coming out of a relatively reactive maintenance environment, you're going to have to start with a much lower ratio, something like 1 to 10. And you're going to have to accept that in the first 6, 9, or 12 months, many of your job plans won't be fully complete. They will not be of great quality just yet. You're going to have to go through several continuous improvement cycles so that you can slowly increase the quality of your plans. And then over time, you can also slowly increase the ratio of planners to techs. Now, a good tool to use here is the wrench time calculator that I offer for free on the site, and I discuss it in the course. Now, the wrench time calculator allows you to see how many technicians you can afford to train up as planners and still increase your productivity. So download it and definitely have a look at it. It's associated with the article, How to Sell Maintenance Planning and Scheduling to Your CEO. In terms of the scheduler, I always advocate a single scheduler per site because you want your scheduler to integrate work across the different trades or disciplines. And in almost all cases, this is feasible. Maybe not in the very largest of operations. As for never having scheduled before, that's not really an issue. As part of the implementation process, you just need to make sure key people understand the principles behind maintenance scheduling, why you do it, and how it should be done. It isn't that difficult, and because the role of scheduler is not really a very technical role, unlike that of a planner, I actually often recommend you find someone from outside of the maintenance team to become the scheduler. It makes it a little bit easier in terms of resources. An operator who understands the plan could be a great scheduler, but you could even take a talented resources from your admin pool. I've seen that work. I've actually used it myself very well, very effectively. All right, the next question. Joel from Quebec asked the following question. What are the KPIs used to measure maintenance planner performance? Well, there are many ways to assess the performance of your planner and your planning process, but often these are more qualitative measures like how well the feedback loop is working between your maintenance technicians giving feedback on job plans and how effective your planner is in implementing that feedback. Or there are measures that are not really a reflection on your planner's performance like backlog and various backlog measures. So when it comes to measuring planner performance, I do recommend that you look at these measures like feedback loop and backlog measures, etc. But you also really need to track estimating accuracy, both in terms of costs and hours. And they are very much a clear indication of the quality of your planner's work and his or her performance. Now, I normally recommend that on a monthly basis, you basically compare all completed work orders and assess how much the actual hours or the actual cost varied from the planned hours or the planned costs. And improving this accuracy over time really helps to improve your your planning and scheduling efficiencies, as you don't end up with a schedule that is either overloaded with too much work because all the durations were overestimated, or just too empty. Now, sure, this is probably one of the most direct measures of planner performance, but even this measure is impacted by others because, in this case, it's how consistently and how accurately your technicians are time rating. But please don't let that stop you. Estimating accuracy, both in terms of hours and cost, is one of the most important measures to use when it comes to maintenance planning. And I would strongly recommend you start tracking it and track it consistently, because you want to be looking at the long-term trend. Okay, another commonly asked question, and in this case was first asked by Nina from Brazil. What's the best way to manage backlog, and should I aim to have no backlog, and is that even possible? Alright, so explaining how to manage backlog is an intensive topic and something I actually dedicate 2 whole lessons to in the course. But in short, I always recommend that people manage their backlog by splitting it into 3 buckets. The first bucket is plannable backlog. This is the work that still needs to be planned. This is the bucket that is owned by your maintenance planner. The second bucket is planned backlog, which is the work that has been fully planned, as we discussed earlier in the video. But it's not yet ready to execute because the parts and materials haven't yet arrived, or maybe you're still waiting on confirmation of external contractors or vendors. Again, this bucket is owned by your maintenance planner. And the third bucket is the ready to execute backlog. This is all the work that is fully planned, where all parts and materials are available on site or in the warehouse, and all external services have been confirmed to be available for the required dates. This bucket is owned by the scheduler, who's going to draw down work from this bucket based on priority and load it into the weekly schedule based on capacity. Now, there's obviously a lot more to managing backlog. You need to get your maintenance supervisor involved, you need to get operations involved, but we can't really discuss that here. As for trying to have no backlog, that's another discussion in itself, but certainly not something I would aim for. Instead, I would typically recommend that you aim for about 4 to 8 weeks of corrective work outstanding per trade per discipline. If you have a lot less, you likely have too many resources, or you're in a very active maintenance environment. And if you have much more than that, you're probably carrying significant risks to the longer term integrity or reliability of your plant. But those numbers are very much dependent on your plant and your asset and where you are in the world, so don't take them for gospel. But again, what you want to try and do is express your backlog in terms of number of weeks per trade, and then trend that over time and see whether it's steady or increasing or decreasing, and you get a better handle on whether you're in control of your backlog or not. Alright, well, that brings me to the end of the questions that I'm covering in this video, and it certainly was a bit longer than I expected. We're over an hour and a half by now. So I just really wanted to thank you for being here and taking the time to watch this presentation. I really enjoyed putting it together, and I hope you enjoyed watching it. If you are excited about implementing maintenance planning and scheduling in your organization, then you are definitely in the right place, and I would ask that you just head on over to roadtoreliability.com/MPS, and you can enroll right away and get started. If you do still have any questions, or you want to enroll multiple students, then just drop me an email. Always happy to help. Once again, thank you for your time, and I sincerely hope to see you on the inside of the course. Take care.